So hi everybody. So I still remember my first talk in this conference. I think it was in 2010, and I think that the conference has grown a lot. So I'm here again, and I'm very happy to be here again. We are going to talk about testing for user interfaces, but I must warn you that this talk is going to be technical, and I had a bad taste to show some code. Okay, so you are fairly warned. Okay, who am I? I'm Enrique Amodeo. I'm living in Berlin. I'm working for SoundCloud, and I've been doing software developing for a long time. And I'm test infected because I like to test a lot. And this talk is based on my new book about testing. It's a compressed summary of 3 or 4 chapters that are in the book. So if you are really interested, go ahead and read it. So, what's going on with all the stuff about testing, right? Because when I mean testing, I mean driving things using tests. So you need to test first and then write the code. What is going on with that? I'm hearing a lot that this approach, which is called TDD, is fairly dead, okay? But there are a lot of people trying to kill it, but it seems that not really dead yet. Why? Because it works, okay? What happens is that there are some problems in the way that people are using this approach. And most companies I've seen that are doing either one of these things. Or they are testing every unit of code, every class, individually. So this is a big problem because the tests we are doing are focused on technical things and not really on the value for the point of view of the company. Or they are testing everything together, and then you have brittle tests, a slow test, and a test that when it breaks, you never know what is the culprit, or where do you need to start to fix it. So none of these approaches are really good. What we just really need to do is do TDD right. And just to add a new fancy name, we call it BDD. Doing TDD right is doing BDD. And what is that? So to do BDD, just you need to take the system, slice it, the system into problem domains, and then for each problem domain, you need to look for the right stakeholders and talk with them and comprehend their necessities and what the system should be doing from that point of view. And then you test exactly that and not other things. But this is very difficult because you need to be able to discover the stakeholders, to talk with them in a fairly frequent way and without any weird thing going on in between. Right? You need to collaborate. And this is a problem in most of the organizations, and that is why most of the organizations are doing either unit tests or end-to-end testing, at least in my opinion. So once you have defined these problem domains, you just need to write tests for that. Okay, one test, one behavior of each problem domain. 2 behaviors should be able to be tested independently, so we need to isolate these tests. And if there is something external to the core concern or your problem domain, you should mock it. And that's all. Okay? And obviously, refactor often, but this is another story. And what has this to do with the UI? Because what happens is that I never see the people who take seriously this BDD approach when you test UI, right? And then you end up with a lot of weird things. I'm going to try to explain to you how I use BDD to design my tests around the UI, because the UI is another piece of your software and you should test it, at least a bit, okay? So what is the first thing you need to do? You just need to decide, okay, I have this thing called the UI, the user interface. what are the responsibilities, what are the problems domains that are in the UI. Okay? Obviously, not the business rule. Obviously, it's not about calling the network stack to communicate, calling with the service, this is another thing. It's just rendering, right? Maybe in the past it was just rendering, but nowadays we have a more complex UI, so we have a bit more of things going on in there. So actually, in my experience, in most of the cases, you have two different problem domains that are totally separately, and that you should test separate in a UI. One of these is the presentation domain, which is basically the just rendering part. And the other is the UX domain, or how the user interacts with the UI. So our UI code should follow this architecture. If the previous slide is true, if we have these two problem domains, we should have these two boxes here. One is called passive view, and it's about the presentation domain, and the other is the UX logic. It's about UX interaction, and we should have this kind of architecture, these two boxes separated and collaborating through a kind of a contract. Okay? In most of the cases where I saw code about the UI, I don't see this separation. It's everything spaghetti. And this is a main problem. So I'm going to explain a bit. I'm going to use a bit of jargon here. So this is a user. For example, if we are in a web UI, you have the DOM. If we are in Android or in iOS, this will be UIKit or whatever. So the user interacts with the screen, and the screen will generate lower level events. Things like a click, key press, mouse over, tap, or whatever. Okay? These are intercepted by the view, and they are transformed to UX level events, which is different from the other ones, right? These UX events are things like add product to an order. This is one event, or request login. Okay. There are things that are meaningful from the point of view of the actions that the user pretends to do with the interface, not with what is going on physically with the UI infrastructure. Here we do a lot of processing. We intercept the events, the UX level events. We do processing about it. We maybe call the server through XML HTTP request or another network start, does not matter, REST API or whatever. The data comes, then we think a bit more, and then we end up with a new view model. A view model is just a passive data structure which contains all the data that we need to render in the screen. And not only the data, it contains which controls are visible or not, and maybe if we need to change to another screen, or which controls are enabled or disabled. Okay, but it's really playing all data object there. Okay, and the passive view takes this data structure, this data object, and it simply interprets this and updates the screen. So this way of dividing this stuff has an effect, is that most of the important logic we have here, okay? And this is very thin, especially now, because if you use a good framework, for example, in the web, for example, you use React, this is mostly declarative, right? It's a very thin layer that it's stateless, and probably if you're using the right framework, it will be mostly declarative. So it's very trivial to build, okay? So the most complex logic that we have is here, because this is not stateless, is stateful. We need to save to remember where the user is in which screen or in a flow or things like that. Okay. So we want to test this. So how we do it? So for example, we can use an OGS, or you can use a JVM with a JUnit, or you can use your favorite unit testing stuff or whatever. This is the old tools that we all know. Okay, because this is clearly plain old code. There is nothing about the screen there. There's nothing about the details of the UE infrastructure, because all these details are here, not here. Okay? So this is a traditional test, in the sense that the ones we have been doing all this time. We just need to stop the network layer, or even better, we just mock our server API client library that you usually have one. So we just mock it. We just mock it, inject it through dependency injection, because we are doing that. And when we want to test, we just prepare the mock, send these high-level events to this guy, and check this object, this plain old data object that is coming back. It's fairly straightforward. We can use, as I said, normal tools on your normal development platform. In JavaScript, for example, we can use Mocha, Chai, Sino, or whatever. In Java, you can use JUnit. In Scala, you can use specs too. Let us be a bit more explicit about what are the behaviors we are really testing here in the UX logic layer. Okay? So this is a cucumber that represents a very small example of the kinds of things that I test when I test this layer. So in this case, this is one of the behaviors that this layer is a formatting. So it says, OK, I want to display the order price. So if the order total price is $1,000, and the user is from USA, when the user displays the order, he will be shown as total price exactly this stuff. Right? Here, under the hood, what we have is an instance of the view model set up with exactly that data. Right? And here, when we say, OK, we say to the view to render, we should send to the view exactly this thing to render. So the view does not need to make any decision about formatting. OK? So you can see here that there is no reference at all how the UI looks. It's only how the UI works from a logical point of view. But I'm not saying here nothing about text fields. I don't know if I'm presenting this with a text field or a nice graph with a SVG or whatever, right? This is not the responsibility of this layer. It's the responsibility of the view. Another example, right? Validation. If the user fills 100 in the quantity file, right, there will be an error. Okay, so the quantity field should be highlighted as erroneous, and then we should show an error message. I'm not saying anything about if I need to put this field in red or put a small asterisk over there. I'm not saying anything about that. Just it should be shown as erroneous. Okay, and show this message. And the same thing when we try, for example, to add 2 cappuccino to our order. Okay? We just call the server, and the server, if we are calling the server, we need to wait for the server, so we need to disable the UI and show some kind of a progress feedback to the user. Okay? So this is all very, very nice, very easy, and with that simple techniques that are the old techniques that we have been doing all the time, you can really test most of the UI. Okay, so you really don't have a problem with that. And I wish that more people were seeing like that, because then everything goes much easier. So what do we do with the passive view? The problem with the passive view is it needs to talk with the screen, with the UI infrastructure, and probably, as I told you, we are using some fancy framework there, right? Because I want to use the framework because it's easier, okay? So we can say, okay, it's very declarative, it's very thin, we don't test it. What for? We should only test something if we are going to get a return of investment there, right? So if it's declarative, easy, it's not much code, and almost never fails, why should we test it, okay? On the other way, we should be using only the framework, or our version of the framework does not support the latest bugs in all our browsers, or we are not really confident with what we are doing there, or we have a lot of reports that we didn't test it, but we are getting bugs. So probably we should start testing it, right? So at the end, I say, start here, do not test the view, but if you really discover that you need it, you need to test it, okay? But as a default, you start not testing, but then you can see, okay, maybe I was too optimistic for that, okay? But with this approach I'm proposing, the passive view is very thin, so it doesn't have many pathways. So the amount of tests that we need to do for that are very small. If we try to test everything together, we are mixing the pathways on the UX logic with the pathways of the view, right? So we need to make a test when the field is wrong, a test when the field is not wrong, and test when the server make a timeout and whatever, right? And those tests are slow because we need to talk with the UI infrastructure, we need to use complex tooling, it's brittle, right? So it's much better to do as less tests and this layer as possible. And this is one of the motivations why I slice this, the UI like this. The other motivation, as I told you, is stakeholders. Probably when I'm talking about the view, I would like to talk more with users or graphic designers, and these are my stakeholders with the view. With the UX logic, I can talk more about how it should work a bit more with the business people, with the UX designers that are not the same thing, not the graphic designers, okay? So this is the other motivation. So imagine that you are in this situation. We say that I didn't wanna, but I'm forced to do that. I know there will be a few tests only, but I need to do it anyway, right? What can we do? So there are a lot of tools, a lot of frameworks, but if you are using a web UI, for example, a rich web application, the most common and mature tool out there right now is WebDriver. But WebDriver really is not a tool. The tool is Selenium, but WebDriver is not a tool. The WebDriver is just language-neutral protocol. Okay, it's language-neutral protocol that we can use to remote control the browser. Okay, and one of the implementation of this protocol is Selenium. Okay, so the important thing of this is that you can use a client library for this protocol in your test. In Java, we have such a library, and in JavaScript, we have 2 of these libraries. Okay, you choose the one that you like more. So even if you are not using WebDriver and you are using another thing, the concepts are the same. So all of the things I'm going to show is easily extrapolatable even if you are not using a web UI, because at the end, everything works the same way. So before starting with this technological terror, let's focus on what we need to test. Okay, we are testing the view, and one of the responsibilities of the view is rendering. And this is the test, render order. When the following order is rendered, the action of the test is render the order, and I define the order, defining what information is coming in the view model. Under the hood, the implementation of this step will be to create a data object with exactly this information. So I have the information to render and which forms are enabled. When I do this action to render this form, then I need to check in the screen if the total price field contains exactly the text that I say that it should have. Exactly. And if these forms are enabled or disabled. And this is how we do it. In this case, with WebDriver, Node, and a web UI, but you are using, for example, iOS or Android, you just change the names of these boxes with other tool in that platform, and it works the same. Okay. So what we are gonna do is just to instantiate a passive view, right? And tell them to render a given view model. This will update the DOM, and then we will read the DOM using WebDriver to check that the action was okay. Don't worry, you don't really understand the detail of the code. It's not important here. What is important here to say that this setup is done once, only once for all the tests, because it's slow. And what we are doing here is just open a new browser and go to the page we want to test. And then, once we are there, send a script that will instantiate a new instance of my view. In this case, this is called for a React view. Okay? Because we are only navigating to the page and instantiating the view only once before all the tests. After each test, we need to clean up all the fields. Okay? In order for each test not to interfere, the result of each test need to be cleaned up, not to be interfere with the next test. Okay? And this is much faster. Loading once, cleaning after each test. And of course, then we need to execute the action of the test itself. It's again, we just send a new script to the browser and say, hey, I have this view model, which is an object. It's a plain object with all the stuff we saw here. Okay, you see, it's exactly an object with exactly this structure. Right? And we send it to the browser and we say, hey, view, render this view model. And that's all. And then, of course, we need to assert that the test is okay. So for that, we just tell the WebDriver, yes, I know that in my view, I can use this CSS selector to locate the text field of the price. And then we check what is sitting there, and it should be the price, right? And this is important, and this is good, because we are testing the view, and this is responsibility of the view to handle how is structure of the DOM, right? So this is okay to have this stuff here, right? We are no longer abstracting about how we are rendering things, because this is responsibility we are testing. Okay, what I can tell you is that if you put here a CSS selector, do a very generic selector that take less assumption as possible of the specific structure of your HTML. Okay. And what is the other responsibility? capture low-level events and generate, let's say, user gesture, user-level events. For example, if we want to add a product to our order, how can we do that? It depends on how we design the user interface, right? So in this case, it's an example. I can do it two different ways. I can do it adding the data to a field and then pressing enter, or I can add the data to a field and then pressing a button. We have two different low-level buttons, low-level events. For example, the press enter or click submit button that end up in the same higher level event. That is add a new product to the order, right? And there is a trick here, right? I'm inserting a bad quantity here. Error is not a meaningful quantity. Obviously, it should be 1, 2, 3 cappuccinos, but not error cappuccinos. But the view is not responsible for validating. So it doesn't make any judgment of that. It just passes error cappuccino. She doesn't know if this is good or not. This is a responsibility of UX logic. Okay? And again, if we send an event here, it will be captured to the passive view, and then it will transform to the user gesture that goes to the UX logic. But we are testing, so we put here a spy, and we just assess what happened to the spy. It's pretty simple, right? So this is the code that just, as we saw before, we just are instantiating the view. We pass the UX logic that is just a spy, and then you will render. We fill the data. Okay. Interesting. And we send the enter key in one test, and in the other test we send the click event. And the answer is the same for both. We just, the UX logic got called with exactly the expected event, with the expected payload we had in the test. Okay? So, as I told before, you do that if you really need to test the view. Why? Because all these tools, WebDriver or whatever, have a lot of bugs, usually. At least this is my experience. It can be a bit tricky because we are emulating a human user, so we can have a lot of problems with the timeouts and things. It's not a very clean thing to do, but it's the best we can do right now with the technology we have. Okay, so again, the assumption is that you are doing this, but not only for the really, really, really important things in the view layer, not for all the kinds of things that you need to do in a UI, because these all kinds of things are already in the UX logic. Okay, and you already have tested separately. It's slow. This is another bad thing. Slow tests hinder your feedback cycle. And maybe you can go very fancy and have a grid and to speed up tests. Because you can notice that each test, the setup is very clean with mock objects, so you can run them all in parallel. And you won't have interference with them. Is this the best that we can do? Actually, no. We can do it a bit better. Actually, the code I showed you before is very, very bad. Because when I took my test and I read the test, what I'm concerned about is the behaviors. And the code I showed you before is more about WebDriver. Okay, there are a lot of noise there. I start reading the source code of my test, and I say, hey, what is the logic here, right? It's a lot of stuff about WebDriver, accessing a screen, whatever. This is not good. The other bad thing is that if I change WebDriver for another tool, or if I upgrade WebDriver and now we have another API that is incompatible with the old one, I need to change all my tests, right? So when we do these kind of things, we always need to apply a very important design pattern here, which is the page object. And this is what I'm going to talk about now. The point of the page object is to create an object that represents every module, reusable module, that you have in your UI. Okay? It's a bit misleading because we say page object. So we tried, in the beginning, the people were trying to create an object that capture the whole screen. But it's not about that. We are building screens nowadays around a smaller reusable module. So this is the things we are targeting, really, right? Because a screen at the end is just a composite of these modules. So I never test screens as a whole unless I really want to do that. As a default, I test only modules, UI modules, which is much simpler. So for each one of these UI modules, I create an object. We have methods to access the data that they are presenting, and methods that allows me to manipulate this module, like submitting a form or whatever. The point is that this object will will encapsulate all the nasty details that you need to do to make WebDriver work. And then you write the test according to the API of this page object, right? And then you have a clean test when you see exactly what is happening. That reads much similar to the cucumber I showed you before, right? Let's see some examples. For example, a method to access data in my module. In this case, my module is the order, okay? So we just create an object which has a function, it's called total price, and here I hide the WebDriver detail, the find element with that selector, and then get text. This has an additional goodness, not only because of the things I told you before, but what happens if my designer change the way I'm showing the price. In the test I showed you before, you need to change the test because you need to change this selector, and maybe it's not a text field, it's another thing, and I need to change this stuff. So I need to go to all the tests that are accessing the total price and change it. This is a brutal test, because if my designer change only the way we are rendering, I should not be doing much changes. And this solves this problem, because if that is the case, I just go to this thing, change the code there, and done. Sometimes we need to access several stuff, several fields, to create a representation, okay? In this case, it's just a line, order line, so I want the name and the quantity, and I want to return them in a single object, okay? We can also encapsulate the way we do forms, and this is good because in modern user interfaces we have a smooth, we have a homogeneous way of making the user interact with forms. So we have the UX patterns, right? So we can encapsulate that thing in small objects like this. For example, I know that in my application, in the forms, you type the text in some field names, then you press the key, or you click submit. And this is an homogeneous UX pattern for all my applications. For example, your application will be different. But in my application, I can either press enter or click submit. So I isolate this logic here, and we can reuse it here. In this case, the order have total price, product line, and a form, right? So this way, I can build a small library of page objects that isolates me from WebDriver details, the most specific details about exactly how is the DOM structure, and I can reuse common UX patterns, and then I can make tests very easily of my view. This is my last slide, so just some advice. Do not put assets in a page object. The responsibility of a page object is just encapsulating WebDriver and very fine-grained detail about the structure of the DOM, but not testing. The asset belongs to the test, so do not put assets there. Okay? And for God's sake, no navigation there. Why? Because the view is not responsible for the navigation. This is the UX logic, right? Don't put anything about navigation in your page object because the test of the view shouldn't have anything about navigation. Okay? That's all.